So I've got about, I think like half a dozen of you left to grade for that first homework. So that I should get that done before I leave today. Or I'll just do it tonight at home. We'll have that kind of second homework due dates coming up. So make sure I get the exact date right. Where's that? All right, so the 25th. Excuse me. So that's what? Next Thursday, right? So by the end of the day, you can turn it in class next Thursday if that, if you've got it done, or you can kind of upload it just like before. So one thing is I'm grading, I kind of notice, make sure you're reading carefully. And if it asks to put, to use a graph, make sure you're using a graph. Probably on most of them, there should be something that, you can kind of draw at least some type of a graph that would kind of help lead you to the correct answer. Even if it's not required, a lot of the times it's just going to make it more likely you get the answer correct, right? Having some kind of visual to go with it. Other than that, any questions for me? Yeah.
Is there any way you can go over the question number 2 on the quiz that we do today?
Let me see. So you've got a win maximizing team, and they set a salary cap minimum that's greater than the team's current expenditures. So which of the following is most likely to occur? So let's kind of draw this out. So as I'm reading this, and I'll kind of make this bigger. The team will experience negative profits. So they're win maximizing. Yeah, you would drive them negative profits, right? Let's double check. I'm sure that's. Yeah, that should have been it. So I'll kind of go through that. So we've got a team that's currently win maximizing. We've got the number of wins. We'll kind of use this constant marginal cost. And we'll say something like this. So we've got the demand, marginal revenue. And we know that their win maximizing would be that point where marginal cost hits the demand curve. Okay. So win maximizing. If you put a salary expenditure minimum, right, that's past their current expenditures. So it would translate to a number of wins that's past their current number of wins and current expenditures. So salary minimum. If you were to do this and force the team to spend additional money, what's going to happen? Well, we know that when they're win maximizing, profits are equal to 0. So if I force them out to a point out here, well, you kind of think about if profits are equal to 0, every point past here, marginal revenue is way below marginal costs. So I'm just going to be decreasing profits even more. So if I were to force them out to this number of wins, I would know that their profits are negative. Is that can I get you? And then I'll probably go back through. I'm actually going to give everybody credit on that third one for a while. It was up there. I was typing it out quick, and I think I put, what did I do? I did NBA instead of NFL for every single answer, even though the paper talked about the NFL. So, I mean, all the rest of the stuff on after it made sense, but because it was the wrong league, I'll probably just go back through and give everybody a point for kind of who submitted that assignment on that one. Okay. And I was waiting to do that until past the due date, so I'll get that done after class today. Any other questions kind of before we jump into things today? All right, so we've been talking about kind of competitive balance and thinking about some of the things that we might see that are related to that. So that's where we kind of left off, mostly talking about salary expenditure minimums and maximums. We also think about things like how the promotion leagues are going to influence this. So, you've got this promotion league in European soccer where teams that perform poorly in the higher quality league are kind of demoted, and then teams who perform well in the lower quality league are promoted, right? So the idea being, you're getting rid of the bad teams, putting in higher quality teams. Maybe you're trying to guarantee that all your high quality teams are in the high quality league, lower quality teams in the low quality league. That way, year after year, you're kind of guaranteeing that there's more competitive balance in those leagues, right? That the teams are more similar in quality. Okay, so we would think that it helps improve competitive balance. We can kind of think about something, maybe indirect effects as well. So if we look at the variance on just the wins, and it's a little bit different because there's a lot more ties, but you can still look at win percentage variation, right? So the level is lower, but the variation we can kind of still compare. Excuse me. In fact, just to kind of review this, kind of a statistics thing that may come up occasionally, just kind of having a reference point to talk about it. If I'm thinking about what my win percentages, right? And I'm thinking about what does the distribution look like, right? So I can come up with the measure of variation, which is the variance of the standard deviation. So let's say, that the mean win percentage in something like the NBA, where we don't have ties, right? Well, there you can expect win percentages to be higher because you won't have to share some of them with a tie category, right? And so the mean is likely to be higher than the mean in other sports that have ties. So maybe something like, actually, it's a screen one. What do I want to think about? So if their win percentage, there's more variation. I want more variation in. So I'm going to have something like this. And that's going to represent the distribution for the win percentage in, what is it, European soccer leagues. Kind of measure them as a whole. Right. So because there are things like ties, the mean win percentage we see is probably going to be a little bit lower, right? And it's also going to be that distribution is probably a little bit more peaked. What that's telling us is that it's more likely, right? We can kind of think about what's really on the x-axis when we're thinking about what's on the y-axis when we're thinking about distributions. It's really the probability measure. So you can kind of think about it's more likely, or there's a higher probability that we see values really close to the mean for European soccer, as opposed to the values really close to the mean, a little bit less likely, right, when we're looking at the NBA. So we've got kind of a more spread out distribution, right? Or at least that's what we would expect from this promotion league, right? Or for instituting this promotion league, right? We're kind of trying to guarantee that the win percentage across the teams is going to be relatively small. Every team is going to kind of be very competitive. They all going to have similar records. Right? So it's just kind of a way of drawing it out using distributions. Right? You primarily teach this, as an econ course, but right, some stats kind of have to enter the equation at some point. So that's kind of what we're thinking about. So we see a much lower variance, right, or lower variation in that data. So that's why I had that more peak distribution. There's always going to be, like, even if you are a low quality team, you don't want to get demoted. So even if you can't win the championship, right, there's a huge incentive to win, because if you don't and you end up being one of those bottom teams, you're going to be demoted to a league that doesn't offer as high of that doesn't correspond to as high of revenues, right, or can't generate as much demand. However, so that's one measure we have about the kind of competitive balance. Another measure we started talking about was like who's winning the championships, how much turnover do you have at the top, and we actually see kind of for the European soccer leagues, the turnover tends to be much worse. So you kind of tend to see that, and when I say turnover is worse, I actually should phrase that slightly different. Like the turnover doesn't occur, right? I guess thinking about turnover being a good thing, the turnover is worse, right? In the sense that we're not getting as much. And so you can think about why. So I just mentioned those teams at the bottom, even if they can't win the championship this year, have a huge incentive to try to win. That's not demoted. So what you kind of end up with is that they can't take years off. All right, so I think we're accustomed in American sports to thinking about a lot of ebbs and flows with a lot of teams, right? They have rebuilding years. They have to take a couple of years off, not spend as much money, so they can have or restructure contracts so that they can have a good season. So you can't really do that if you're going to get demoted, right? And so you constantly kind of have these teams who are just kind of status quo, right? They're kind of staying in the same spot year after year, while those high quality teams in the top league, right, they're just continuously staying at the top there. So we kind of end up seeing, yes, there's less kind of variation year to year in the win percentages, but we tend to see the same teams kind of cycling there up at the top. Right? So it really depends on what you want. I mean, I don't have haven't seen a good study on this, but what you would ultimately want to do is try to estimate demand, right, or try to get an idea about what consumer demand is and how that's related to season by season kind of variation in wins, or see if it's more responsive when you use a variable like, is there, do we see higher TV viewership, higher attendance when we see turnover there at the top, like a new team entering kind of the top 3 or the top 4 best teams or whatever, however number you want to put on it. So we've got different measures, and both are flawed a little bit, right? Both have their pros, both have their cons. Okay. So with this idea of taking a year off, right, we're going to think about what every team's decision is, which is that hopefully the goal, even if they are profit maximizing, they would enjoy additional revenues if they're winning championships, things like that. So what the result or what the decision comes down to is maybe I can keep my team competitive for 10 years, right? So we can kind of remain in the top half of the distribution or the top half of winning teams. But if I don't take any years off, it's going to be hard for me to accumulate young talent. Maybe it's going to be hard for me to go out and spend more money on free agents because I haven't kind of tried to restructure or kind of cut certain players. And so if I kind of remain constant for 10 years, I may not win a championship. However, if I attack things in a way in which I'm kind of going through those cycles where I've got some down years where I'm able to kind of acquire young, cheaper talent and then go out, sign larger free agents, right? Maybe I can kind of win a championship every 5 years, but the 5 years in between might be some pretty rough seasons, right? And so, there's, I guess, kind of depending on the makeup of the team, depending on the makeup of the team, one of these may be more attractive than the other. We kind of think about that's what a team's kind of internal struggle would be, because there's a trade-off between these things, right? So a lot of times we talk about things like in the current season or in the current year, but really these teams should be maximizing profits or maximizing wins, not just in the current year, but over a multiple year time span, right? And those models become infinitely much more difficult very quick. And so that's why we kind of focus just on the year-to-year changes. It would probably be like, I don't know, to really model this out correctly, it would almost be like a master's level kind of attack, right? I don't think, I'm trying to think of any of the course where you've done, might have seen some dynamic stuff, but probably, I guess there are some models in IO, but for the most part, right, at the undergraduate level, we kind of try to keep things static, right? So, but in reality, it becomes a much more complicated question. So the next thing we're going to talk about that affects competitive balance, or at least the way it's instituted currently is, I think, if you think off memory, I don't want to say this without stopping to think. I don't think there's any of the top 4 leagues that don't have a reverse order draft, right? NHL, NBA, and MLB, and NFL all kind of have what we call reverse order draft. So this is the idea that the lowest quality teams, or the teams that won the fewest games, they're going to get the top picks first, right? And then kind of as we move down the list, once we get to the team that had the most wins, they'll get the very last pick in the draft. So what is this trying to guarantee? Well, if I have an earlier pick, I can more likely get a higher quality player, right? So I'm trying to take those teams that perform poorly, low quality teams, and add them better talent than the talent that the high quality teams are going to be able to add in that draft. So the reverse order draft is really trying to improve competitive balance, right? So kind of already talked about this. And that's really the goal, right? Exists in all leagues. So we think about, what might the incentives of reverse order draft be? Well, if you're a good team, you don't really care much, right? If I'm, thinking about I'm trying to make it into the playoffs, or I'm trying to win the championship, I don't necessarily. It's not a huge difference in the 22nd to the 24th pick, right? It's always better to be earlier, but it's not much of a difference there. Whereas when you're talking about going from being the number 1 to the number 3 pick, right, there could be substantial drop off in talent, especially depending on the year. Okay, so for good teams, they're not really going to be affected much by this reverse order draft. But those poor quality teams who know that doesn't matter, no matter what we do this year, we're probably not getting into the playoffs. And so if I'm not going to make it into the playoffs, I might as well just be the worst team in the league and get the top pick, right? That's kind of the thought process, right? So we might have this incentive for low quality teams to do what we call tank, right? So this idea of tanking, and we'll kind of talk through this, but which league would you expect to maybe have the worst kind of problem or the biggest problem with tanking? Let's try to think about some of the things that might also make it more or less beneficial. Right? No guesses? So why?
Less games, so it's more easy to see if a team is actually tanking. Well, I don't know how many games.
Yeah, one game is a much larger swing, right? Losing one game in the NBA is not going to, like, you can get halfway through the season and you can almost, I mean, if you look at like the betting lines for like who's going to be the worst team, there's like one or two teams, like you almost already know, because there's just such a small number of games. Like once you get halfway through, if you think about like Major League Baseball, I mean, you still have 81 games left halfway through. Like there's still a lot of movement that can occur. And so if you look at the betting lines of baseball halfway through about who's going to have the worst record, there's still a handful of teams, and none of them are like real bad odds. Like they're all, kind of, about the same probability. So yeah, so the number of games, right? And this brings up a point that will kind of pop up later. But if I'm playing more games, what's true about even just the value of each game? It's going to be less. So the same kind of idea there. If I have fewer games, the value of each game in terms of how much it's going to swing my likelihood is going to be a little bit higher.
I was just gonna ask, like, so what would you say necessarily, because I thought initially it'd be NBA because there's less, like we said with the NFL, as you add talent, the marginal revenue per person.
Yeah.
But in NBA, there's obviously less talent. There's less people that play in like a rotation.
Yeah, so I wouldn't say that there's a right answer to this question. Like it's more of us to get us thinking, right? So what you're saying is true. Whoops. If we think about what's some other things that vary across these sports, well, the value of one player is going to be dramatically different across these sports. I mean, the value of a player is going to depend, first of all, how many players are on the team or on the field / court at the same time. So for that reason, you would think maybe NHL or NBA, one player, right, it can greatly change the quality of a team. And so, or maybe in the NFL, a quarterback, like there is one position, you could argue that that player has so much influence over how many wins that team's going to get, that it's really important that we can get the highest quality player, right? So yeah, that plays a role as well. So you could probably argue a little bit NFL, smaller number of games, quarterback position being so important. NBA, NHL, fewer number of players at any point in the game or on the field or court. What's maybe something else that would kind of influence? If you think about the specific to the reverse order draft, you're thinking about the value of having that number one pick. So what might happen if you go from pick 1 to say pick 5 across these different leagues? So maybe, let's think about it this way. Excuse me. So maybe if we're just thinking about, let's say we could arrange all the players, and then we're just going to plot them in terms of the highest marginal productivity all the way to the lowest. And this will enter in, we talk a little bit more about the labor market, I think a little bit after the first exam, our first exam. But usually think about it as the marginal product of labor. How much additional units that worker is going to add to production. In sports, we kind of call this the marginal wins that are coming from labor, right? The number of additional wins, that wins are our product. So the number of additional wins that each player brings in. So if we think about the distribution, it may be that in the NFL, it looks something like this. As I'm looking at the highest quality player all the way to the lowest, so you can almost think about it as here, if we kind of ignore for a second, like specific team needs, like if teams were just going to draft the best player, so like not positional needs, the first person, the first pick, the second pick, the third pick, kind of what the value of each player would be. And maybe, I would argue that maybe in baseball, if you look at like their draft, the best player in the draft is probably not going to add near as many additional wins. First of all, there's just more, I think if you look at the marginal number of wins that players add, and you kind of account for the fact that there's a different number of games in each season, Major League Baseball starts out a little bit lower, but you can still get decent players. Like, I don't even remember how many rounds. It's a ridiculous number of rounds in Major League Baseball's draft. But you can look at the 5th or 6th round, and they're still drafting players to become pretty productive, right? And so maybe in Major League Baseball, that like drop off in talent at the top isn't near as much. If I have the first pick or the third pick, well, kind of that decrease or that change in the marginal number of wins that those players could add, notice that change was much larger for the NFL, right? And so maybe like how quickly kind of the talent you expect it to drop off at the top of that draft might also really kind of influence what league it makes, has the biggest tanking problem. I don't know if I've ever seen, I know I've seen the comparison of Major League Baseball to NFL. I don't know. I can't remember off the top of my head, like compared to each other where like NBA or NHL would be. My guess is that the NBA would be relatively steep as well. Like you can kind of imagine going from like pick 1 to 5, like you're already, decreased quite a bit there. I don't know exactly where it would be at in relation to the NFL. My guess is it would be somewhere in between the two. But like if it ended up being a little bit sharper, a little bit steeper than the NFL, I wouldn't be shocked. Right? We can, so there's multiple kind of factors that are going in there. Okay. So, all right, I already said this. So what's a solution to this tanking problem? Well, one league has tried to deal with this, which is the NBA, right? So might be a good indicator that, the NBA was having a pretty big problem with tanking, or at least thought they would, if they just instituted a pure reverse order draft, where if I'm the worst team in the league, I get the top pick. So what they did is they just made it not certain, right? So if I'm the worst team in the league, I still have the best chances of getting that top pick. But they do what's, kind of this lottery where they're picking, I don't even know if they still do, they still pick out the team balls or whatever. Yeah, and kind of whoever gets picked, right? If you were the worst team in the league, you get more balls in this like kind of bingo spinning thing. And then if yours gets picked, you get that pick. So, you still have the best likelihood of getting the top pick, but it's not guaranteed if you're the worst team in the league, right? So that kind of helps a little bit, because then I'm like, well, yeah, if I'm the second worst team or the third worst team, my chances go down a little bit, but not a ton, right? So there may be not as much of an incentive to tank there. So when would these reverse order drafts be effective at improving parity? So I'm talking about this as though having that top pick is definitely going to be good. So what might be some things that would break down the effectiveness of a reverse order draft at improving competitive balance in subsequent years? Or maybe a trait or a characteristic of those teams at the top who are getting that top draft pick, what could maybe they do wrong to screw that up, like so that they're drafting high quality players, or at least they have a pick where they could draft high quality players, but somehow they're not getting better over time.
They pick a player that they know they can get short-term revenue, like doing it now.
Yeah, right. So actually, it could be that their incentives are still profit maximizing. Maybe they're not win maximized, right? They just want to add players. I think I would argue it's probably down in Dallas has a similar problem, right? The Cowboys, where they want to draft flashy players, but they're a large market. They know they can bring in a bunch of money. Like that might be the profit maximizing thing. So just like with other things we looked at, when we try to close that gap in small and large market teams, we said, what prevents it? Well, small market teams are profit maximizing. Giving them more money doesn't help anything at all. Giving them a top pick, if they're just going to be profit maximizing, might not help things at all. So that's one. What's something else that they could be pretty bad at, or that they might do wrong?
As far as having the ability to trade picks, because they might have people in the office, because obviously like the GMs and the head coaches might not agree on the pick that they're wanting to have. So like I believe the GM has the say over the trade and stuff like that.
Yeah, so that kind of almost hits two things. So the first is kind of similar to the first, what we were talking about before, right? I can trade my picks away if I'm purely profit maximizing, if I can get more trading that pick than I could from having that player on my team and generating revenue. The second thing that kind of brings up is the GM may not agree with the coach. So what's the difference there? Well, their evaluation of the talent, right? If they both had the same belief that there was a player that was, real high quality and going to, change direction of the team, they would draft that player, but they disagree on the evaluation, right? You look at mock drafts, they're always different orderings, right? And so if teams who are getting that top pick are bad at talent evaluation, well, they're going to pick the wrong person. Look at the Browns, right? Taking however many quarterbacks like in the last 20 years. So, maybe you just have a poor talent evaluation. The reverse draft order isn't going to help us improve competitive balance, right? So there's kind of like three things that we talked about. I guess the two are kind of closely related to just profit maximization. But yeah, did you have a?
No, I was just gonna say that's the Anthony Bennett effect.
Oh, just pick it, yeah, and also not only is talent about, so that brings up the last thing I want to bring up or point out with regards to this. So if I'm bad at player evaluation and I get a player who ends up doing absolutely nothing once they make it to the professional league, what's an additional problem of having that player? Expensive, right? And so sometimes having these top picks, in fact, this was a problem. I don't know if I have it here. I don't know if I have it in the slides here today, but if not, I might Google it for us. You can see like the NFL had a huge problem with this, right? I don't remember how long ago now it's been, 10, 15 years, but they actually instituted some rookie minimums, right? Or not rookie minimums, rookie maximums for how much a rookie contract could be. Because it was happening, it wasn't so much coming from just the player, or it wasn't coming from the teams not wanting to pay people. It's coming from the fact that, well, I was low quality, I got a top pick, I got to spend all this money on this rookie quarterback, and then they end up not, the chances that they end up being successful are pretty low to begin with. And now I'm stuck with this huge contract. How am I supposed to get better over time? Right? And so it was almost like it was a curse to kind of have some of those top picks if the salaries were going to be as high as they were, which is then you saw teams trading them away, right? Because they knew the value they could bring in terms of money was a lot higher by trading the pick as opposed to what that player could actually bring in to the team if they drafted them. So I think we mentioned all these. Let's see if I forgot any here. So we talked about quickly diminishing margin utility. If teams can't evaluate talent correctly, we kind of talked about the profit maximization and the fact that these players are also very expensive. So I think this is the paper that I posted up on Canvas, but if not, we'll have an additional one. Yeah, so we'll talk about this now. Where is it? So it's kind of a longer paper. In fact, I don't even think this was an econ journal. Yeah, this is in a management journal, but it's pretty interesting. So we'll go down here and I'll kind of hit the main points. Okay, so this is, I tried to draw this out for you earlier, and hopefully I got it pretty close, right? But this is kind of looking at the overall draft picks. And they tried to come up with this way of estimating what the value of these players were. Okay, so what kind of compensation or what kind of value they had relative to the best person in that draft class. And you can kind of see it falls off pretty quickly, and then kind of levels out, right? So if I'm thinking about, I don't even know what rounds of these transfers this would be, about the 4th to the 5th round. Like, there's not a whole lot of difference in the value of the players in the 4th to the 5th round. But if I'm looking at pick 1 to 15, ooh, man, that drop off is quite a bit. Right? So the way they came up with this, let me see if I can find the equation. I don't think I scrolled past it yet. Yeah, so they're still talking about their data, blah, blah, blah. Here we go. So the first thing they do is they run this regression. Right? So I'll kind of write this out more simplistically about what they did. But basically we can think about what was their main concern. So they were looking at compensation of players, right? And I'll kind of simplify it. They were doing something like taking the natural log. It changes the interpretation of our coefficients. I'm not going to do any log model stuff in this class. So let's just act as though it was just kind of compensation. So, and I think compensation was, where did they say it? I can find. Yeah, so what their kind of amount of money they're being paid that went against the cap would be, right? Then they had all these other performance variables on the right hand side. So what they're really thinking about was, can I predict how much someone's going to get paid using things like, I don't know, how many touchdowns they scored, I don't know, receiving yards, right? And you'd have to kind of include all stats here, right? So across positions. And then maybe you want to include things like indicators. So maybe was the player, do they play the position of quarterback? And that would just be a 1 or 0 variable. And then add in indicator variables for every other position as well, right? And maybe you want to throw in some year controls as well to control for what the year was that the draft was occurring. So, before I go back to the slides. So if I do that, and I run this regression, I can come up with estimates for all of these slopes. Right? And then what I can do is, okay, now I've got these players, right? All I'm going to do to come up with what their predicted compensation would be is I'll have values for all these, right? This little hat, this means I'm going to have some estimate, some value for this that comes from Excel. So maybe it's something like, I don't know, I'm just going to make some numbers up. Maybe beta 0 was 100, beta 1 was 5, beta 2 was, I don't know, 1.2, etc. And then all I'm going to do is take a player, I'm going to plug in their number of touchdowns. Maybe they scored 10 touchdowns. Maybe they had 500 receiving yards, right? So I plug in 500 here, plug in 10 here, and then it just basically becomes a really long equation, but it's a pretty simple equation, right? I'm just adding up each coefficient multiplied by whatever that player's value was for that X variable. Right? So running this regression allows me to come up with some coefficients to predict every player's compensation. Does that make sense? Any questions on that? I think we've really kind of explored as much about the prediction side of things, but that's what the usefulness of these coefficients are. We can then come up with predictions for not even a real player. We could come up with predictions for a hypothetical player, right? Just if we would kind of need to know what the statistics of that hypothetical player would be. So once they do that, they kind of know what they can predict compensation. So we come down here. I'll come back to some of these in a second, but this is the main part. So they've got this p hat, which is really going to be the valuation. So we looked at how, the predicted compensation from all these different statistics. Well, I can then come up with for this player based off of what their performance actually was. What was their valuation, right? How much would a team be willing to compensate them? Okay. So they have a predicted amount of compensation that players should be getting. And then they just subtracted the actual, right? So let's say I have a player and I predict that I should be paying them $10 million. And I look at it, I'm only paying them 5. Well, my surplus there, the benefits that I'm getting, that player's value is $10 million, I'm only paying 5, it's a net benefit of like $5 million. So they come up with what they call a surplus measure for every single player because they can predict their compensation, they can look at their actual compensation, right? And what they do is they don't just do this by player, they do this by draft position, right? So it's not so much that they're doing individual like hypothetical players or predicting compensation for players, but the way that they actually do is they calculate surplus from each draft position, right? So they predict what that person's compensation would be in that first draft spot, the person who was drafted first. They then look at the actual compensation, and the difference between there is kind of the surplus value, right, of each one of those draft picks. So if we then look at, well, I can plot, and so that's when they were coming up with these predicted compensations, that's what they were using as kind of every one of these dots was like a different player, right? You can kind of think about there was multiple first picks right across however many years of data they had. And so they were just plotting every single player's kind of predicted compensation here. So that would give us kind of, based off the statistics, this is what the distribution of talent should look like. So then I'm just going to plot on that same graph, and they just kept the line of best fit for what that compensation, or sorry, the predicted compensation, or what they call performance value was. So that's this guy. They then looked at the actual compensation for these different different picks. And then the difference between the two would be the surplus. Right? So notice initially, the surplus value of having a worse pick is actually going up. Right? So having that 15th pick in the draft, right? The surplus value is pretty high. Yeah, I can't get as high of a performance of a player, but the gap in between how good the player is and how much I end up having to pay them, much larger. Now, eventually, I get to a point, looks like it's going to be around the end of the first round. Now that surplus value starts to go back down, right? So really, if I'm looking at this and I'm a team trying to make optimal decisions, if I had one of the top picks in the draft, unless I have, obviously every team, the value is going to be a little bit different depending on positional needs. But if I'm looking at this, generally, what picks are the best to have? Yeah, right. Somewhere around middle to late of the first round, right? That's where the surplus value is at its highest, right? And so, you think about if I've got one of these top picks, okay, unless I have a dire positional need, I probably can get more by trading that pick than I could by kind of actually using it, or at least my surplus value. If we're talking about in terms of dollars, right? Maybe not win maximization, but profit maximization. You would be more likely to see teams trade away these top picks to kind of some later in the first round. And the result is because when I have high performing players, I also have kind of high compensation values. Right? They did kind of this as well, like kind of the expected surplus from trading that pick, and it kind of translates to, you know, you'd see the highest values of kind of middle to late first round. So it's kind of interesting. So it really brings up this idea that, you know, sometimes we can run multiple regressions, right, and obtain information that, you know, so for instance, here they first ran a regression to then predict compensation. And then they're looking at a different statistic, which is this surplus measure, right? So you can kind of do things in multiple steps. It doesn't have to always be everything is linear regression, but this is kind of a good combination of multiple statistical analysis here. I think that other thing that they then do is, okay, and then we don't have to know, spline regressions are a little bit different, but they're trying to pick up the surplus that exists in these different rounds. So see if they got the table down here. I thought they had another one. Oh, I thought there was one more I wanted to cover. Maybe I was, is it higher up? Let me see. So they put the results. Footnote. Oh, supplementary analysis. Never mind. I have the wrong version of the paper. So this was in an older version. They basically ran this regression and looked at this surplus measure and then just included indicators for what round the draft pick was in. And I believe they find kind of that, you know, the highest surplus is actually associated with that second round. And then they go into, in another version of the paper, they break it down more into like picks 1 through 10, 11 through 20. And then they kind of find that middle to late first round. And then early the second round is really where you kind of see the highest surplus measures. Any questions or kind of comments or anything on this? It's kind of an interesting kind of paper to bring up. We're going over the draft order. And so I think, you know, we already talked through all of this. So they regress position and performance measures to get the compensation of players to predict their compensation. They then find the difference between that prediction and actual amount paid and value that as surplus, or call that surplus to the team. It's decreasing after rounds kind of 2, but we kind of already said, you know, it's actually increasing initially as we're going kind of from the first draft pick. And yeah, so the last player chosen kind of has 25% of the value. So this is getting at the idea that player talent, that distribution is falling quickly, but so is compensation. It's just that compensation is falling a little bit quicker. And or if you think about it, it's starting out at a little bit lower of a point than the actual kind of quality of that top pick. And so initially, right, that ratio or that difference between how much they should be paid versus how much they are, initially that's going to actually kind of get smaller, right? Because the compensation falls so quickly from pick 1 to 2, even though the talent really doesn't, right? And that's why we saw that kind of initial increasing surplus. Right? So, if we allow teams to trade these picks, right, how is this going to impact competitive balance? Right? Well, kind of mentioned, you know, depending on the positional needs, maybe there's teams that actually value that pick a little bit higher. And so now we come back to what we talked about on Tuesday, which is this invariance principle, right? That whoever values those top picks the most, that's going to be the team that ends up with it. Because even if, you know, the Colts have the #1 pick, if somebody values it more than them, there's going to be an amount they can come to agreements with, or certain players that are valued certain amounts where they're going to trade, right? And the team that values that pick the highest is going to be the one that ends up with it because they'll trade for it. Okay? So the invariance principle should kind of still hold here, unless we have high transaction costs, right? So unless kind of the agents being involved, you know, unless we've got really, yeah, that's the main one, right? Agents and I guess, yeah. That'd be the additional transaction cost that might break it down. But those are relatively small kind of compared to the salaries we're looking at for players. So it's unlikely that it really is enough to kind of break that down. The only other thing that I did want to mention at this point for the invariance principle is it gets a little bit weird because it could be, it's not so much the evaluation of the pick, it gets a little bit more complicated because teams, the value of a pick is dependent upon what other teams are going to do. So the value of the second pick can be very, very high, right? Let's say you've got a good draft class with like 4 or 5 good quarterbacks in it, right? The value of the second pick could be very high if the team that has the first pick doesn't need a quarterback, right? Because if I know that they're going to not take a quarterback, that second pick might as well be the first pick for my team, right? Because we would pick this, the same person if we were in the second position or in the first. And so sometimes it's not so much the valuation of the pick, but it would be the valuation of the players that kind of drive where we see these trades occur. So it may not look like the invariance principle kind of is playing a role, but it really is. It's just that the teams aren't really trying to think about what their valuation is of the pick, but more the valuations of the players or the expected players remaining in the draft at that point. Okay. So, some of these teams that have, poor quarterback talent, they might hold on to it more because they really, really need a top pick to get a top of the quarterback. Whereas teams already have good quarterbacks, they won't value those top picks near as much, right? They can still get the players they want by drafting 5, 6, 7, right? After they know that, all the players or all the teams above them are going to choose these quarterbacks that they don't need. We're also going to see market size play a role where, once again, larger markets, right? The same player is going to be able to generate additional revenue in LA or New York that they can't in Cleveland. And so we'll see like large market teams be more likely to be the ones that are trading for these picks, right? Or trading up for picks. Okay. Any other questions or kind of comments here about the reverse order draft before we keep moving? Okay with this. So the next thing we'll kind of talk about, and it's slightly different, but I think it's kind of interesting, is maybe not thinking so much about the top 4 sports leagues, but maybe things like tennis, right, or golf, where you've got winner take all tournaments, or at least a prize structure tournament, or prize structure tournament. So the better you perform, right, the more revenue or more money you're going to make. So here, it doesn't matter how good you are, right, in the sense of your pay or your wages are going to be highly dependent not on your absolute ability, but on your relative ability, right? If go back, I don't know about golfers these days, but right, if you show up and the 10 best golfers aren't there that day, right, it's much more likely that you can get higher wages because the prizes are not given out by who would do the best if they were here, but who actually performs the best, right? So we see this in, like I said, golf, sometimes like tennis. And we can kind of model this and determine what we'll think about as optimal effort choices, right? Now, optimal effort, you can think about this in like number of hours spent practicing. We can measure it on more of an intensity level, like even though you put in the same 5 hours, was it higher quality hours? Like, were you more focused? Like, it's really hard to measure effort, but we can at least get predictions about how effort would change when we see some different things with these tournaments. So we think about generally that players' utility is going to increase with 2 things: income and leisure, right? My utility goes up when my income goes up. My utility also goes up when I can have more hours where I can, not work, right? So the struggle is, right, to find a balance where I'm working enough to have the level of income that rises my utility, but not working so much that I'm losing out on utility from not having my leisure hours. So we generally think about effort, right, or time is a good way to think about it. Like I said, you can also measure it in terms of quality, that it's costly to individuals. And so as I put in more and more effort, right, it's going to be more and more costly. The easiest way to think about this is in terms of time. If I put in 1 hour, I'm going to choose the hour in that day that I didn't have the fewest things going on. I wasn't really sacrificing anything. That's the first hour of my day I'm going to give up, right, from practicing or whatever it is. The second hour I give up, well, it's going to be a little bit less more free than the first one. I'm giving up maybe going to hang out with my friends or something. So it's a little bit more costly. Well, eventually, as I keep adding additional hours, I get to a point where, well, now I can't work. So now I'm giving up whatever the wages I would have been earning when I was working. So every hour is a little bit more costly because I'm kind of using my time. I'm using whatever time I value the least first, right? I'm not foregoing a lot of other opportunities by practicing in this hour. So we can think about how we could model this. Think about the thing that we're choosing. It's not quantity, it's not wins now. We're just thinking about a player level effort choice. And they're going to value that effort. And like I said, if it's easier to just think about effort being like the number of hours, that's okay. So it's how much will I value each hour, or how much do I value putting this effort in? And this is also kind of involving like psychic costs, and those are hard to measure. But this would be the idea that even if it's not measured in terms of hours or minutes, right? The harder that I have to focus on something, it just mentally is more costs me more mentally. And so you can think about it that way as well, to where we really kind of have this increasing marginal cost curve, or what's really going to represent the effort supply curve. Okay. So what is demand going to look like? So in these tournaments, it's kind of odd. But if you think about the most simple tournament, 2 individuals, whoever wins gets the top prize, whoever loses gets the second prize, which is often 0, right? So if we just do it that way, so let's say first person gets all the money, second person gets nothing. What's the value of kind of winning that tournament? Well, my marginal benefit or my marginal revenue is going to just be whatever the difference is between that first prize and that second prize. Now, often that second prize is 0, so quite often that marginal revenue just ends up being whatever the value of the first prize is, right? What's the additional revenue earned from winning versus not? So where does the marginal benefit equal the marginal cost, right? Or marginal revenue made from this tournament equal the marginal cost? Call this E1. So it's a little bit more complicated than that when we have more than 2 people, right? Because I would even say it's not simply the difference in the first prize and the second prize, but it's really like my expected value. We actually would want an expected value, because I'm not guaranteed I get first by putting in more effort. Right? So it gets a little bit more complicated than that. So we actually would want to do like the expected marginal revenue, right? Which would be the amount of that first prize multiplied by the probability that that person gets first, right? Based off of the kind of effort I'm putting in, what's the probability I get first? And then add to that the value of the second prize multiplied by the probability that I get second. Now, if it's a 2-person tournament, these should add up to 1, right? My probability of winning and my probability of getting second, those would be kind of all possibilities. But you can imagine if there was like more than 2 people and multiple, you would just keep doing this, right? Value of third plot prize plus the probability I get third, et cetera, et cetera. And you're really kind of building up kind of this expected marginal revenue from putting in a certain level of effort. But we'll kind of keep it simple. Like I think about it as a 2-person model, and we won't kind of build expectations in, but I did want to kind of mention that because we'll start to think about how we calculate expectations. And all we're really doing, and if you go back to 221, this is really like a discrete random variable, right? Where I've got a couple different outcomes and their associated probabilities. So it's like a weighted mean, where I know if I add up all my probabilities, those should always just be 1. So I don't have like a denominator there. But really I'm just taking every single possible outcome, right? The different prize values, multiplying by the probability that that prize value occurs. Okay. Any questions on that? So one thing, since we've already got this here, well, I'll go back to the slides and we'll come back, add some stuff later. So we kind of already went through this. The optimal point is where the marginal cost is equal to marginal revenue. And so we think about like, having these rank over tournaments, it should kind of have a pretty high level of effort. Right? So do they work, right? So there's some pretty interesting kind of work that's been done in this, and won't necessarily open the papers today, but I'll kind of give you the highlights, and I think it's pretty interesting. So, someone was looking at the final round of a golf tournament. Ehrenberg and Bagnano, I think that's how you say that last name. But what they found was, they looked across all these different tournaments, that when you had a higher total prize money, the golfing scores tend to be lower. So you can't ever really directly measure effort, but we think of performance as a function of effort, right? So if effort went up, we should see performance go up. And that's what they see when the first prize amount is higher, right? So that makes sense, right? You think about when the prize is higher, what's going to happen? I probably didn't leave myself enough room necessarily here. I'll have to extend my supply curve a little bit, or my marginal cost curve. Let's say the amount of money goes up. Kind of think about it as that optimal level of effort would be predicted to be higher. Right? So when I'm increasing that first prize, right, I'm going to kind of increase that margin revenue curve. I should see more effort put in, which is kind of what they find, right? That performance went up. But it's not just the overall amount, right? So let's imagine I had a tournament, 2 people, and the top person gets $5 million. Right? But the second person also gets $5 million. What's my marginal? Where would my kind of marginal revenue from winning the tournament be there? Yeah, the additional revenue I get from getting first is actually nothing. So I think I got a blue marker over here. So really my marginal revenue curve is down here. Where does that hit marginal cost? Well, the way I do it doesn't even hit marginal cost. So you're actually at 0. You just put in 0 effort, right? If I know I'm gonna get 5 million one way or the other, I'm not gonna be super focused on that. Right? Now, obviously I'm using a very extreme example that kind of, you probably would model things in like, well, it's not just the money, it's, the love of winning, the love of the game, all these things, right? We could build in some additional utility. But if we're just thinking about the incentives that are being created with the prize money, 0 incentives being created from the prize money. It would have to be purely intrinsic at that point. Okay? So it doesn't matter just the overall level, it matters what the gap in the prizes are, right? The relative size of first to second place. Okay. And so they also found that the greater the gap, holding constant whatever the top prize was. So this is like the thought experiment of what they were able to do with the data is if I saw all these tournaments, I could look at ones hold constant where they all had a $10 million first place payoff, but they had varying second place prizes. And then if those gaps were larger, what they saw was performance went up, which is, an indicator that potentially effort went up as well. It's not a guarantee, but it's at least part of the, it's a good first look at it. There's also another paper, and this was pretty famous back in 2011, a lot of press, but it was this thing on the superstar effect. And what they found was it's not just that the prize money matters, right? It goes down to this expectation thing. So if I think about it's the expected marginal revenue, well, the prize money increases the expectation, but what also increases the expectation? My probabilities. So if I go out and play golf and I play against Tiger Woods, I have 0 probability of winning, right? So my expected marginal revenue goes back to 0. I don't put any effort. Right? I mean, what's the point, right? I'll just take the second prize and drive around the golf cart for the afternoon. However, if I'm going up against Tiger Woods and I'm Phil Mickelson, right? Well, yeah, my probability isn't 1, but it's at least still relatively high. I still have a pretty, relatively high expected marginal revenue, right? And so I would still expect those higher quality players who are closer to the talent level of Tiger Woods to still be putting in high level effort. Right? And in fact, someone like Phil Mickelson, right? You can imagine if they're playing in a tournament without Tiger Woods and there's like nobody else who can really compete with them. Well, maybe the probability he gets first is 1 at that point, right? It's the expected marginal revenue. I mean, the expectation is I could put in 0 effort and still win. I might actually put in a little bit less effort. Right? So it's this idea that superstars, right? It's really the relative kind of ability that matters because that's what's really going to change the probability that people win or lose, or the probability they get certain positions. So, if it's first through 10 or something like that. And what they actually found, what this paper actually found was when they were looking at tournaments where Tiger Woods wasn't playing, and it was during the stretch when he was really dominant. I forget the exact start and stop years that they used in the paper. What they found was in those years where he was dominant, the tournaments that he didn't play in, they actually saw that scores were higher, right, when Tiger Woods was in the tournament. So this is the idea that some of these people might have been deterred because no matter what level of effort I put in, my probability of winning is still 0, right? So my marginal revenue is lower. I put in less effort. I see lower performance. Right? That's another interesting paper that's kind of related to this idea of whether or not these tournaments work. And the most interesting one I really liked, I think I came across this paper when I was in grad school. And I know we don't have one here. Some of you are in game theory, right? Or have taken it. So you might have probably got introduced to like experimental or behavioral economics. So we do some economic experiments. So this was kind of in that same vein. But they went out and they found a bunch of elementary school kids, fourth graders, it looks like, and they had them run, right? So the first thing they had them do is just go out and run alone, right? It was like, I don't know, 20 feet, some short kind of sprinting distance, and they timed them, right? So whatever their time was, they wrote that down. That's that person's performance, right? They then had the kids run in pairs. And what do you think happened to the times? Yeah, so they got quite a bit faster, right? So it's this idea of competition, right? Now that I've got something else motivating me, and here it was, I don't even believe they didn't use any money if the kids won. This was purely being driven by what we usually call like the love of winning, right? Just like anytime that there's two people competing, even if there's no prize, we see effort levels be increased when they're in pairs versus alone. And so that was kind of that what this paper was getting at, that it goes all the way back to elementary school. Like it's this love of winning can drive the differences as well. It doesn't have to necessarily be a monetary reward. Now with the boys, what they found was that they really respond to this competition by increasing their performance. They actually found in the young girls was that when they ran against each other, that they actually, what we call exhibit, not necessarily love for winning, but a love for equity, right? And so that we actually see that the girls ran slower, right? And the times, I think the other finding was that the times tend to be closer together when they run in pairs, right? So even if someone could, one of the kids could go out and run it in 5 seconds, when the two girls ran next to each other, that person didn't go as fast, tried to make it so it was a closer kind of race, maybe only ran it in 7 or 8 seconds or whatever it was. I forget. It was a short distance, but so it's kind of interesting that even without monetary rewards, we see that the behavior, the effort choice of individuals highly depends not just on the monetary reward, but also intrinsic motivation. And that's really hard to get at. That's something that's going to be harder to measure, but kind of interesting. So the next thing we'll talk about is cheating instead of effort. Okay? So if I'm just thinking about how maybe I'll model cheating, right? Let's say, what is cheating going to impact in this model? So if I'm taking performance enhancing drugs or cheating, it doesn't change the monetary prizes, but it would change the probability that I win, right? And so maybe by kind of cheating, right, I can increase that probability that I get first and increase my expected marginal revenue. So that's kind of the idea. So we might see that when individuals cheat, we can kind of think about it operating in 2 different ways. So the first is going to be, so they've got their marginal cost to effort. Here's kind of the marginal revenue, right? So we're getting first relative to second. We'll kind of go back to thinking about this as just a simple 2-person model. So here's my optimal effort level. Should be a star. So if I'm cheating, right, I've essentially increased the probability that I'm going to kind of win, right? But it's almost like, it's almost as if I were to look at this function, whatever this probability mass function ends up being, once you kind of introduce cheating your stairs, it's almost like the effort level, this function, right? Doesn't matter what effort level you put in, it's always going to be the same, right? So like the change in this function from a change in E is going to be 0. So it doesn't matter what level of effort I put in, right? I can always expect that I'm going to win, right? And so we might see that the level of effort goes down, right? So how does that kind of operate? How does that get depicted here? So you can think about it as this expected marginal revenue is really going to be marginal revenue as a function of effort, right? And so if that essentially the increase in revenue from increase in effort, I had it constant here, but if it's 0, or if that function is changing not at all when I change my effort level, perhaps I get a marginal revenue curve that shifts all the way down to the x-axis again, and I get very low effort levels put in, right? So I don't know, that's one way you can kind of think about how cheating kind of operates through this model. But at the same time, if it's not a guarantee, if this cheating doesn't guarantee that I win, we could also see increases in effort from the use of performance enhancing drugs, right? And the way that's going to operate is if we can think about at any given effort level. So before I was said, you know, we can think about effort in terms of the amount of time, but we can also think about it as like the quality of time. Right? So if I had the same like quality kind of effort per day, it doesn't have to be measured in the length of time, it's the same quality. If I'm using performance enhancing drugs, maybe that's actually going to be less costly to me. Think about it this way, just in terms of like maybe muscle growth, right? If I put in the same amount of time to the gym, right, I could put in 10 hours and gain 5 pounds of muscle. But if I'm on performance enhancing drugs, I can put 3 hours in and get the same 10 pounds of muscle. So it's almost like I can put in less time and get the same result. So that same level of effort becomes less costly. And it doesn't matter what level of effort I choose, it's going to be less costly to me to provide that amount of effort because of I'm cheating or the use of performance enhancing drugs or however you want to model that cheating. So I get this shift in the marginal cost, and potentially I see that once they're on these performance enhancing drugs, I actually see an increase, right? Or sorry, yeah, an increase in their optimal effort level.
So it's a good thing.
Could be. You might actually see a higher product, higher quality product, right? Because you're going to get potentially increased levels of effort. In the ranked order tournament, there it's a little bit less likely you see increases because the fact that, right, me winning, the probability of me getting first is tied in there. But if you're just looking at, you know, a team sport or something, you're thinking about what each player's individual decision is going to be, you know, the marginal revenue here, maybe it's not first and second prize, maybe it's, you know, being top home run leader in the league versus second with additional revenue that would bring in. And you could potentially see increases in effort in a model like that. It's hard to say. I mean, you know, we've got kind of competing effects. So it's really hard to say which one's going to win out. You know, you can build, I left this kind of blank to draw that graph, right? If compensation gets too high, well, then maybe you're actually going to incentivize people to use these PEDs. Or maybe if that, you know, the expectation, that probability is tied to the effort level, potentially you get kind of lower amounts of effort. Like many questions in economics, it depends, right? Or, you know, it depends on which one of those is larger, which one of those effects is kind of larger than the other. Any questions here? I think I might skip around. Let me see, because I know that this facility stuff, I've got a lot going on. And externalities. We'll introduce this idea. Got another 10 minutes. So this isn't so much related to competitive balance. We're kind of transitioning now to thinking about not so much like league decisions, but team decisions. We talked a little bit about them, but we're primarily thinking about things that the league was doing and how that impacted teams. So when we're thinking about the team decisions, why do we see so many of them consistently building new facilities? Like any Cardinals fans here? St. Louis? No. They just built a new stadium not too long ago. And I think I was there when I was like right before they still had the old stadium, and I thought it was like great. I have no idea why they decided they want a new one. But we see teams do this a lot, right? They're constantly building new facilities. And so why are they doing this, right? I mean, they're huge costs, right? So, I mean, if we look at the costs here, football and baseball stadium, it exceeded $1 billion. Like SoFi was like, I forget, I'll get the numbers wrong if I tried it off the top of my head, but it was something like they proposed $2 million and end up costing 4 or 5. Like, first of all, how are you that far off in your prediction? But, you know, huge amounts of money. So what must teams believe is going to happen when they build these new facilities? That we would hope I can make up for these extreme costs with extremely high additional revenue as well. So I have to believe I'm going to generate more revenue. So how is that going to operate? Probably primarily we're thinking about ticket sales, right? People attending the game. Maybe I can use this space to, you know, hold concerts, things like that. So maybe I can create some other additional revenue sources. But really the primary driver, I mean, a new stadium you're thinking about probably influencing the ticket revenue the most. Excuse me.
I was gonna say you have like a higher probability to rebrand the stadium.
Yep. So I can get additional money by selling the rights to the stadium now, right? So there's a lot of, it's going to affect different revenue areas, but probably mostly, and even when we talked about gate revenue, we kind of said it's really, we can think about any revenue generated from the stadium, concessions, selling the naming rights. But yeah, that's what they must believe, right? So there's a couple of them right here. Just some interesting numbers, right, across these different leagues. NBA, NHL, you kind of see the costs are a little bit lower. Also, what's an interesting thing that we might see NBA and NHL teams do? Share a stadium, right? A lot of these teams do. In fact, if we go back long enough, or go back far enough, there was quite a few football and baseball teams that use the same outdoor stadium, right? And so why are they doing this? Well, I can essentially cut my costs in half. And if my costs are as high as $1 billion, 1.6 billion, that's a lot of money, right? So I don't need to believe that revenues will increase near as much if the costs are going to be only half as much, right? And so we'll see a lot more of these NBA and NHL stadiums kind of being newly built, even probably prior to when they need to be, because a lot of the times they're kind of splitting costs. So the additional revenue that they generate needs to only be, half of whatever it was before. Excuse me. So they must believe that it's going to boost attendance, and then corresponding they can, or not even if we're selling out our stadium, not maybe boost attendance, but boost what? This was on the first homer, so a lot of people kind of did pretty good in this question. But if I'm already selling out at capacity, what does increases in demand do? It doesn't increase the quantity of tickets, increases prices. So if it's not attendance, maybe it's the price that I can charge, right? So usually if we look at the data, we see that this does occur. So after a new facility is built, we tend to see attendance levels be higher, right? Or if we don't, if we were kind of hitting that capacity constraint, ticket prices be higher. But the effect kind of declines over time. So generally, I think there's an MLB study. I probably have it as a bullet point here sometime soon. But they saw like the first 3 years, I believe there was increases in attendance. And then after that, it began to kind of go back down. I think it was something like within 10 years, they were already back to whatever the old levels were. So it appears to be a pretty short-lived effect, right? So pretty short-lived effect of building these new stadiums. They call it so it's MLB that was the paper, right? So they were using Orioles and Indians, but they called it kind of the honeymoon effect, right? You see this initial increase in attendance, but then it kind of goes back to what it was after like somewhere between 5 and 10 years, I believe, was the values they came up with. The impacts are going to be greater in Major League Baseball, NHL, NBA. Generally, because if we just look at the number of games played versus the number of seats, there's just more seats supplied, if you want to think about it, over a given year in those sports than in the NFL. But even if the NFL is kind of selling at capacity, maybe you can see that the ticket price increases are higher than the NFL. I haven't seen anyone really do too much with the ticket price data. It's hard to kind of get your hands on. And also you have some issues of how do I average out luxury suites versus different levels of the stadium. But when we just look at attendance, we see that the effects are a little bit greater in the leagues that have more games. Right? So we kind of already talked about they're selling close capacity. So all they can really do is change price. And so they must believe that improving this or getting this additional revenue, it's going to increase my demand curve. And also potentially, if it increases my demand curve, then in the win market, what does the team decide to do? I mean, this would be kind of a simple one to kind of go through, which is that if building this new stadium can generate additional revenues, and I'm thinking about targeting my optimal number of wins, and we can even use if a team is profit maximizing. So let's say they're profit maximizing, targeting this number of wins. If I see an increase in revenue from building this new stadium, each win is kind of now worth more money. So we see this kind of, call this D2 and MR2. Now the profit maximizing number of wins is going to be higher. Right? So maybe even building this new stadium, not only may I see increases in attendance and revenue, but maybe I'll see an increase in team performance, right? As a result of those additional increases in revenue. Trying to tie, I'll leave this up here a little bit longer. Try to tie kind of these older things we talked about into some of the new stuff. Okay. Any questions on this? It shouldn't be too bad. it's kind of something we've already done. It's just here, the source of the shift is a little bit different. I think we'll pick back up on this on Tuesday, but I did want to go through something here in the last couple minutes that'll help for the project. So we'll come back, we'll talk more about kind of building new facilities, some of the evidence of whether or not it increases performance, increases revenues, increases attendance. But what I do want to show you is more related to the project. So like I said last class, I've got the list of what every one of you kind of chose as a topic and then kind of projected plans for me to gather data for you. As I before I get that data sent out to you, I kind of mentioned that you could start working on other aspects of the paper. And the one that we haven't really focused on when we've been going through these papers is, sometimes it's called background information, sometimes it's called a literature review, right? So what this is trying to do is it's trying to go out and see what other work has been done on this topic. So for some of you, you might find things that are very similar, might be the exact same question as your topic. That's okay for what we're doing, right? But you want to go out and say, here's all the other ways that people have approached this, and kind of build up, this is what's been done, here's what I'm going to do. And then you go through the data analysis and discuss the results. So for that background information or that literature review, primarily what I want you to try to get used to using, I'm kind of expecting that you get at least 2 different good sources. I would say that is a bare minimum. I would try to get, half a dozen, and I think that's very possible for almost every topic that I kind of read through. So I don't remember. It's like scholar.google.com maybe. Let's see if that's right. I always just type in scholar into Google. So if you just go to Google, this is probably the worst way to do it. I just type scholar in, and it's always the first thing that pops up, but it's scholar.google.com, and it'll send you to the same place, which basically starts to search for articles for it, like that have been published in the past. So maybe I'm interested in something like tanking in the NBA, right? So how the NBA can combat its tanking problem. And a lot of the time, tournament incentives. So I can start to look at these papers, and some of them I can't look at. If the title looks interesting enough to you, and maybe you can see sometimes, like I think this one is probably gives you the abstract and it sounds like something you want, let me know, because a lot of the times I can get these, and you should be able to do it through multi-link, but a lot of times I can find older versions of these on some databases that you may not have access to. So if it doesn't kind of give you a link to the PDF, and you really are interested in using that as one of your sources, reach out to me and I can help you if I can obtain it. But basically what you'll do is you'll take this paper, and you won't have to have a great understanding of it, but you can use it and have a paragraph or 2 about kind of what their main findings were, kind of how they approach the problem, and then kind of how that relates to like what you are doing. Because maybe you're interested in tanking in the NFL, but that means that a paper on tanking in the NBA is going to be very relevant to what you're discussing, right? So it doesn't have to be like the exact same thing you're doing. It can be in a different league. It can be in a somewhat related topic. So maybe instead of tanking, we could have even used that valuation of the draft paper. So you could do something like NBA draft value or something like that. I'm sure there's been one there. So maybe there's something about decision-making and kind of how people are choosing different players in the draft, just things that are somewhat related. They don't have to be exact, right? So try to use terminology or phrases that are really close to your question, and maybe search also across different leagues. That's another good way to do that. Or just use general kind of topics. So maybe here, if I'm thinking about tanking, think about like incentives of losing, and maybe you get something like, so this was NBA, but maybe you get like, so here's one, you're looking at kind of tax incentives. So it doesn't have to always be even a sports paper. So if it's just related to the question you're in, so tanking is really all about incentives for poor performance. There might be incentives for poor performance in other areas, like, maybe if I'm the worst performing employee, I don't know, maybe I'm not expected to be on certain committees. And so then that's actually a better thing for me. I don't know. There might be other papers in other realms. So try to start kind of working on that literature review. If you got your question, your topic kind of down, you can start to look for some articles that are related to that. And, I have up kind of some sample projects that have a pretty good literature review section. I'll try to get up some more papers that are sports related that I think have good literature reviews or background information sections, so you can start to use those as models as well. And I'm not expecting you have the level of kind of these peer reviewed published articles, but I am expecting you to like discuss a handful of papers and how they relate to your topic. And yeah, so I just wanted to kind of go through, show you that Google Scholar, probably your best resource for finding those articles. Okay. Any questions for me before we get out of here today? All right, so I won't give you an online quiz today. Probably wait and do one after next Tuesday's class. But try to start kind of working on wrapping up that homework that's due next week at the end of the day, Thursday. And other than that, fun, safe weekend. I'll see you guys on Tuesday. Yeah. I was just gonna say congratulations. I saw your name on the list of 100.
Oh, the top one.
Yeah.
Thank you. I
Yeah,
appreciate it.
I was looking through there for econ majors, and I saw you and Tyler. So I was like, good to see you kind of getting represented. So.
Dr. Bannon nominated me. So that's
Yeah, very
the
cool.
application. It worked out. So
Nice,
I'm
nice.
happy for it.
Yeah.
Put that on my resume. So.
Yeah, that will look good.
Thank you. I
Yeah.
appreciate it.
No problem.
I'll let you know about tomorrow.
You see, like last MLB draft, the local kid that got taken third
No.
in the third round. I think they don't have like a guaranteed money rule, like